All right, y'all. So 2.2, like I said, deals with functions and graphs.
I have a question.
Yeah, I hear you.
If we took the notes and watched your lecture on YouTube last week, do we still got to attend?
No, if you're caught up on 2.2 and you feel good, I'll get new material come up on Tuesday for us.
Okay.
All right, I'll see you then.
Okay. Bye bye.
All right, y'all. So first of all, I'll give us a few definitions and then we'll get into working some problems. So the first thing is our domain. So the domain is the set of all x values. And we can see this as what we call the inputs. So when y'all were graphing the other day and y'all had to pick points, we were picking our x's and then putting the x's into our equations, okay? So the domain is a set of all the x values. And then we got our range. And the range is basically the set of all y values. And you can look at the y values as the outputs. Okay, so an example of domain and range would be, say, your pay. If I had a function set up as pay equals your salary, let's say the salary was $12 an hour, and your pay depends on how much you make an hour times the hours. So on this one, your domain, the domain would be the hours you worked. So you could work 0 hours, 1 hour, 2 hours, all the way up to say 40 hours. Now I won't be looking at no overtime on that, okay? So the domain is the hours you work. The range would be how much money you make. So you could make 0. If you work 1 hour, you got $12, 24, 36, all the way up to whatever 40 times 12 gave us. So notice the domain is the input because you got to input how many hours you work before you can get the pay, which would be the output. Okay. All right. Let's look
I have a
at,
question.
yeah, I hear you.
So the domain is the pay and then the range is the hours?
No, actually, the domain is the hours and the range is how much pay you make.
Okay.
Mm-hmm. So think about it. When you figure out your pay, say you work 35 hours, so you put that 35 into the equation, multiply it by your pay, by how much money you made an hour, and then that'll give you your total pay. And the total pay would be like your range. All right, so then the big one of the day is a function. So y'all, a function is a correspondence. And y'all, correspondence is like shows a relationship between the domain and the range. So a function is a correspondence in which every domain member corresponds to one and only one range member. Okay, so my domain can only be related to one to one range member. So that means that the x's can have only one y value. Okay, so if I did say 10 hours and I was making $12 an hour, I want them to pay me my $120. Okay, you don't want to have a choice because they probably picked the lower choice. So we always want one input and one output, okay? So let's look at some examples. So these examples want us to determine if the correspondence is a function. Okay, so for my first one here, they got the domain and the range. So for my domain, I got 23, 12, and 5. The range they're giving me are 20 and 2. Now here's what they got. The 23 points to the 20. 12 points to the 2. And the 5 here points to the 20. So we need to determine if this is a function. So remember, for this to be a function, the x's or the domain can have only one y value or range. So y'all, let me go through it. I always focus on the domain stuff because that's what we're worried about on this. So the first domain, 23. We all 23 only points to one number, 20. So that's good. The 12. This 12 only points to one number in the range. So that one's good. And then I look at the 5. The 5 only points to one range value. So since each of these domain members only corresponds to one range value, this is yes, a function. Now, we didn't say domain members couldn't share a range value. All we said was that the domain members could only have one y value. So y'all, I'm going to let y'all figure this one out. All right, so let me see my numbers. I'm going to pick 10, 20, and 30. So my range will be a -1, -2, -3, -4. All right, y'all. So the 10 points to -1. The 20 points to -2. And it points to -4. And then the 30 points to the -3. So y'all, the question for y'all, is this correspondence a function?
No.
No.
No, good job. And y'all, the reason this one's not a function is what?
20 is
Because the
22.
20.
So this 20, like y'all said, it's going to -2 and -4. So that's giving me more than one range for it. So good job. That is definitely a no. Now, y'all, so let's see. My domain over here will be 10, 20, 30, and 40. Whoops, let me pull that down just a little bit. So this is like a salary job here. And say the range is $500. So the 10's pointing to it, the 20's pointing to it, 30 points to it, and the 40 points to it. So all these domains are pointing to that 500. But y'all, the question is that a function?
Yes.
Yes.
Good job, definitely. So like I said, this is like if you made 500 a week on salary, no matter what hours you put in, you're going to get that 500 because you're on a salary, okay? So remember, domains can share a range. The only stipulation is that the domains cannot have more than one range value each, okay? All right, also questions on that? Well, that's not too bad. That's just trying to get you used to the idea on whether something's a function or not, okay? So we'll get into what we call function notation. And y'all, function notation is this stuff that you see called f of x. Now, they don't always have to use the f, but this is definitely function notation. You can have an a of x, a b of x. Any letter can be here. So this just lets us know that we got a function. And a lot of times in sciences, they'll put the letter here for what the function's a formula for. Like in science, this might be force because it's a F. Could be Fahrenheit since it's a F. Acceleration, they might use an A for that formula, okay? So this is just notation used to let us know that we have a function. And in all reality, it's almost like the y. You know, when we had like y equals 3x plus 2, well, I could replace the y with f of x. That way I can use it for shorthand when I want to put values in for the x and stuff. So remember, that's just notation and has nothing to do with what you're working, okay? It's just letting me know that I have a function. Now, here's the thing. When they put a number in for the variable, so if a number is given in the parentheses, and they could even put different letters in here. So if they put different letters than the actual variable, then they want us to put this thing into the function in place of the variable. So if a number is given in the parentheses, we replace the variable in the function with that number. Okay? So I'm just going to plug it in. work the function and see what I get, okay? Now the f of x, we don't do nothing with it. It's just letting us know that we got a function. So y'all let me play with one of these and show y'all what I'm talking about here. So they're giving me a function k. And they're saying, hey, given k of x equals x plus 7. They want me to find, let's see, k of 0, k of a negative 17, k of a negative 6, k of 20, and finally, k of a b plus 2. So y'all, this is like 1, 2, 3, 4, 5 problems here. All right, so it looks like I got a question, Nakia.
Yes, I wanted to know, how did you get those numbers? The 0, the negative 17, the negative 6, 20.
Oh, MathLab's giving you that.
Okay, these are
So-
actual examples.
Yeah, so MathLab's going to give us all this up here, okay? And all we got to do is figure out what each one of these is equaling. So this is like 5 little mini problems in one.
Okay, okay.
So they're giving you all that. So what we got to find is them final answers. So let's start with k is 0. So k is 0 wants me to take this k function and see they're giving me a 0 in place of the variable. So that means they want me to put this 0 in for the x in this function here. So I'm going to put a 0 in for the x. So that'll give me 0 plus 7. And y'all, on a function, you only work the right side. You cannot do nothing with this k of 0. It's just telling us what we put into the function. So all we do is add 0 plus 7, which means k of 0 equals 7. So then we got to find k of negative 17. So y'all take this function. Since they're giving me a negative 17, I'm going to put that in for the x. So I'm going to get a negative 17 plus 7. Now y'all be careful on these examples because they're going to give us stuff where we're having to add unlike signs all day long. So y'all, what do you get when you add that negative 17 to a positive 7?
Negative 10.
Negative 10, good job. Let me get my chat pulled over here. All righty. So negative 10. All right, then they said, hey, find me k of negative 6. So I come in, k of negative 6. So put my negative 6 in for my x. I'm going to get negative 6 plus 7. So notice, here we added unlike signs. The larger number was negative, so the answer is negative. Here we're adding unlike signs, but the larger number's positive. So what y'all think? Negative 6 plus a 7. Caitlin, yeah, 1 works perfect. Good job. All right, k of 20. So you notice we're working each one of these the same way. The only thing that's changing is what value we're putting in for the x. So now we're going to put a 20 in. So that'll give me 20 plus 7. And y'all adding 2 positive numbers, that's the easiest thing in the world. So we don't have to worry about signs.
27.
27, there you go. So let me pull out the tricky one. K of b plus 2. So y'all guess what? Guess what I'm going to replace that x with? I'm going to replace it with a b plus 2 because that's what's inside our parentheses. So that'll give us a b plus 2 plus the 7. Okay. So they try to throw curveballs on one of these usually by throwing in a little bit of the alphabet at you. So y'all, here's the question. I got a b plus a 2 plus a 7. Can I simplify this thing any further? Is there anything at all I can do to that?
B plus 9.
I think I was hearing something, but I didn't hear you good enough.
B plus 9.
B plus 9, perfect. Add those like terms, and we get b plus 9. Right, y'all remember numbers add to numbers, so add them numbers, and then now I can't do nothing else because b's and 9s are not like terms. So y'all, that's what we mean by function notation. I got me a function. I know what the variable is. And then this is shorthand. Instead of me saying, hey, put a 0 in for the x, I can say, hey, find me k is 0 and stuff like that, okay? All right, y'all, so let me find my next one here. I'm going to do this one. They're giving us f of x equals absolute value of x plus 4. They want me to find f of 2, f of 3, and f of a minus 4. All right, so first we'll start with f of 2. So that's going to equal, put a 2 in for the absolute value. So that'll be absolute value of 2 plus 4. All right, let's see. The absolute value of 2 is 2. So that comes out as a 2 plus 4. And y'all, 2 plus 4 gives us 6. F of 3. All right, put a 3 in for the absolute value. So that'll give us an absolute value of 3 plus 4. So y'all, absolute value of 3 is 3. So that's going to give me 3 plus 4, which will give us 7. And y'all, I'm going to add one here because they didn't give me no negatives on this one. So I'm going to do f also of a -5 for us, okay?
Okay.
Now, let me do the f of a minus 4.
Yeah.
Now, this one I didn't like on this problem because I'm going to put the a minus 4, and then outside I got a plus 4. And y'all, the reason I don't like this problem, because we can't do nothing to this. What they're trying to get you to do is add this -4 to this +4, but we cannot do that when we got something inside absolute value. They cannot add to stuff on the outside. So this is the only problem on your homework where this is the actual answer. Okay, this one can't be worked because we don't know what that A is. All right, y'all. F of -5. Let's see what we do there. So absolute value of -5 plus 4. All right, y'all. So what is the absolute value of a -5?
5.
There you go. So that gives me a 5 plus 4. And what's that? Looks like 9.
Yeah.
Okay. So just be careful on this one with the absolute value, because when you plug in the a minus 4 or whatever they give you, it's not going to simplify, okay? All right, so let me try a new one of that. All right, so this one has given f of x equals x to the third. We're going to find, and this one got like f of 0, f of -1, f of 5, f of 9, f of -4, and finally f of a -3a. So let's see, 1, 2, 3, 4, 6 of them we got to find on this one, okay?
Okay.
But it looks like all we're doing is whatever number we put in, we're cubing it. So let's start. F of 0. That's going to equal 0 to the third power. And y'all guess what? 0 to any power
That's 0.
is a 0. There you go. F of a -1 will be -1 to the third power. So what sign y'all giving this answer?
Negative.
Because you got a negative times a negative times a negative. What's that going to give us?
Negative.
Negative 27.
Let me put one back in.
Negative.
Oh, I heard the negative, but one
7.
times one times one times one.
It's 1.
There you go. So
23.
that's going to be a -1.
Mm-hmm.
Now, if you got a negative number to an odd exponent, it will end up negative, okay?
Correct.
All right, y'all. F of 5. That'll be 5 to the third power. So what y'all getting on that? 5 times 5 times 5.
125.
125. That's why when I did them cube graphs, I wasn't picking 5s because I'm not drawing no graph out to 125, okay? Oh, look at this one. F of 9. That's going to equal 9 to the third power. All right, y'all. So 9 times 9 times 9.
729.
I think you said it. What did you just say?
243.
729.
729. There you go.
Wow. That's a lot.
Yeah, so 81 times 9 is that bad boy there, okay? And you'll never see me pick a 9 on a cubic graph. That's for sure. Well, y'all be drawing that thing out to 1,000. All right, -4. That'll be -4 to the third power. We know that's going to be negative.
4. 64.
-64.
Negative 64.
Is it because it's even?
Say again?
Is it because it's even?
No.
Even number?
Well, all I'm doing here, that -4 to the third just means you got a -4 times -4 times -4. So if you multiply two of these, negative times negative gives you a positive 16. But then that 16 times that other negative is what's
Okay.
making that, and that's what's keeping
Okay.
that negative on it, okay?
Mhm.
Now, if this was an even exponent, my answer would be positive. Okay. All right, y'all. F of a negative 3a is going to equal negative 3a to the third. That exponent affects everything in these parentheses. So we got to figure out what is the negative 3 to the third power first.
Is it negative 27A?
Yeah. Mhm.
Oh, you're so close. Keep me going, though. Because think about this. You got an A times the A
Many times.
times the A. So we would write that as what? An A
To the third.
To the third?
to the third. There you go.
Oh, wow. Okay.
So we would treat this like, oh, I got a negative 3a times another negative 3a times a 3a again, okay?
Mhm.
All right, so let me show you an actual application of doing this stuff. And let me see if y'all know what this formula is for. So given f of c equals 9/5 c plus 32. Y'all recognize this formula? Nine-fifths C plus 32. Oh, my schools are slacking these days, ain't they? Well, y'all, let me tell you what this formula is. This formula converts the Celsius temperature into the Fahrenheit temperature.
Oh,
So this gives the Fahrenheit temperature corresponding to the Celsius temperature. And so the reason that's a 32 at the end, in Celsius, water freezes at 0 Celsius. So if you put that 0 in, 0 times 9/5 is 0, and 0 plus 32 gives you the Fahrenheit temperature, and water freezes at 32 in the Fahrenheit world.
right.
And you could do that with like water boils at 100 Celsius. And if you plug that in, you'll get, what is it, 212 Fahrenheit where water boils and all that fun stuff. Now, what they want to know, though, they want to find the Fahrenheit temperature equivalent to 25 degrees Celsius. So my Celsius temperature is 25, so that means I'm going to find F of that 25. So y'all, that means we take our little function here and replace our C with our 25. So we'll have 9/5 times 25 plus 32. So I'll tell you the truth. If you got a fraction times a whole number, you can multiply the tops, then divide by the bottom. Or if either one of these will divide by the bottom number, you can divide first, then multiply.
Yeah.
So I could do 9 times 25. That gives me
It's too much.
2 something, and then divide that by the 5, okay? But watch this trick. You can take the 25, divide by the 5, and make that a 5.
Correct.
And 9 times 5 now gives me 45,
That's 32.
plus 32 for a Fahrenheit temperature of
77.
77. There you go. Now, MATLAB will have the little degree thing and the F. All you got to do is put in that 77, okay? Little bit warmer than room temperature. So 25 Celsius is around room temperature, maybe a little warmer, okay? All right, y'all. So any questions on that?
Mm-mm.
All right, so then what it gets into a little bit more graphing. But now instead of using y equals something, they're using that function notation. So on this one we're about to do, we're going to graph the function. And my function is f of x equals -1 plus the absolute value of x. Okay. Now, they're giving you the x values. And then they're giving us our little table to fill out. So x, they'll give me 5 x values on this one. And I got to find the f of x or the y values for each one of these, okay? Once we get all the values, then we graph it. So the values they're giving us on this one are -2, -1, 0, 1, and 2. And remember, this is absolute value. So in MATLAB, it's going to be that 2-point absolute value tool. Now, when you do this, it's really important that the middle number is the first one you plot, okay? And then you can pick any other number, because whatever's in the middle will give us the V point on that, okay?
Okay.
All right, y'all, so let's see. We're going to put in a -2 first. So we would basically have f of -2 is going to equal -1 plus absolute value of -2. Well, y'all, you got to work the absolute value first, so bring down that -1. So what is the absolute value of a -2?
2.
So now I got -1 plus 2, and that'll give us a 1. All right, so then we put in our -1. So f of -1 will equal -1 plus absolute value of -1. All right, y'all, so bring down the -1 again. Absolute value of -1.
1.
And -1 plus 1. What a big old 0.
Yeah.
Now remember, these V-shaped graphs, we should start seeing some symmetry over here before long, okay? And by that I mean these y values are to start sort of showing a pattern. So let's do f of 0. -1 plus absolute value of 0. So bring down that -1. Y'all, absolute value of 0 is a 0.
-1.
And look at that, -1 plus 0.
-1.
Now watch this. Since that's the middle point, I bet right here for the 1, we get the same thing we got at -1.
Mm-hmm.
And at 2, we'll get the same thing we got at -2. Because y'all, ain't the absolute value of a -2 the same thing as the absolute value of a +2?
Yeah.
So here we go. Let's do the 1. So -1 plus absolute value of 1. Well, y'all, there you go. It's going to match up to this one perfectly. That's going to bring down that -1. Y'all told me absolute value of 1 was
1,
1. And look at that. -1 and 1 is
0,
0. So I'm pretty sure we know what's going here. What y'all think?
1,
2.
Because there's our -1 plus absolute value of 2.
1,
So remember, that's just like I had right here, right? -1 plus 2. And that's going to give me my value of
1. Mm-hmm. Makes sense.
So remember, first point you would plot would be that one. Always do the middle one on these graphs, okay? On this one, is more picky though, because it is the absolute value. And then you can pick any other point on it. So we've got our table right here. So in MATLAB, so there's my X and my Y. So in MATLAB, I'm doing 0, -1 first. So remember, 0's in the center. Go down 1. And then I would probably go right 1 and pick 1, 0, because it's an easy point. So go right to 1, stay at 0 for the Y. And y'all, at that point, MATLAB is going to come in and make you a V-shaped absolute value, okay? So this is just more work on graphing, but they're giving you the X values on these, okay? Oh, y'all, let me see. And I'm trying to get some of these trickier ones for y'all. So question on that one? All right, let's try this one. We're going to graph f of x. And really, I think the main reason they're doing the graphing again is get you used to this f of x as being pretty much the same as your y's, okay?
Okay.
But y'all look here. X squared minus 2x minus 6. So this one's quadratic, remember, with the x squared. So the quadratic one's going to be the U-shaped graphs with 3 points on it. And remember, it could either open up or open downward. So let's see what they're giving us on this one. So x and f of x. All right, so they're doing -1, 0, 1, 2, and 3. Now, they're giving you the numbers that'll give you a perfect center part of the graphs. So this middle number will always be the minimum points on these or the maximum points on them, depending which way it opens. Now, this one's not as picky, so we can just do our 3 points and be done. All right, y'all, but look at this. F of -1 we'll do first. Now, it is really important if you do this on your calculator, you got to put that -1 in parentheses. Especially when you square it. If you don't put a -1 in parentheses on the calculator, let me show you what it does. Because remember, any number you squared has to be positive, right? So watch this.
Yes.
When I put my -1 in parentheses, and then I square it, look, I get a 1, which is right answer. But watch what happens if you put a -1 and square it without parentheses. It does not square the negative if you don't put it in parentheses, and it gives you the wrong answer. It gives you a -1. Okay? So when you're plugging in for a variable and you're putting in a negative number and it's got exponents, put that thing in parentheses. All righty, so here we go. exponent first. -1 times -1 is a +1. And y'all look here. This stuff right here can be multiplied. So you really got 2 times -1, which is -2, but you're subtracting a -2. So remember, when we subtract a negative, that becomes a +2, and then bring down that -6. So I did -1 times 2 here, and then these two negatives made that a positive, and then I brought down to 6. So now I got 1 plus 2 is 3. 3 minus 6.
-2.
Oh, negative
3.
So now put in a 0. F of 0 will be 0 squared minus 2 times 0 minus 6. Well, y'all look at that. 0 squared is a big 0. Minus 2 times 0 is a 0. Minus 6. So 0 minus 0 is 0. 0 minus 6.
-6.
-6. There you go. All right, so then we got an f of 1. F of 1 will equal 1 squared minus 2 times 1 minus 6.
Mhm.
All right, 1 squared is 1. Minus 2 times 1 would be minus 2, and then minus my 6. All right, y'all, let's see what that's giving me. 1 minus 2 is a -1. -1 minus 6.
-7.
-7.
All right, so I'm halfway down this thing. In my middle was 1 -7. So I'm going to start expecting numbers to start looking like these other numbers up here. Because these U-shaped graphs, these parabolas, are symmetric also. So let's see what we get with f of 2. That'll be 2 squared minus 2 times 2 minus 6. So let's see, 2 squared is 4.
Mhm.
Minus 2 times 2, which is 4, minus 6. Oh, and y'all look at that. 4 minus 4 is 0. And 0 minus 6 is minus 6. So now we're starting to see the symmetry. I got a -6 here, -6 here. So I'm pretty sure we know what's coming here. F of 3 will equal 3 squared minus 2 times 3 minus 6. All right, y'all, let's see. 3 times 3 is 9. Minus 2 times 3, which is 6. And then minus 6. All right, y'all. 9 minus 6 is 3.
3.
3 minus 6.
It's 3.
And that thing is a
-3.
-3. There you go. So see how you got your symmetry? Your middle number is -7, but then you got -6 on each side and then -3, okay? So on that one, we're choosing the U-shape 3-point quadratic. And then always do my middle numbers first on these out of habit. So I would do 1 -7 first. So go right 1 and down 7. That puts me right here. And then I would probably do one close to it on either side. So 2 -6 will be over 2 down 6. And then 0 -6 will be on this side. Go down 6. And at that point, Math Lab will come in and draw our parabola. Now remember, this thing keeps going and going and going. So y'all be careful. Remember, always use parentheses with negative numbers. That's probably the biggest thing I can tell you on those, okay? Now, y'all, this one are given f of x equals negative x squared minus 1. And then let's see what numbers they're giving us. So -2, -1, 0, 1, and 2. Now remember, that's another x squared graph. So that thing's either going to look like a opening up parabola, or it could be a opening down parabola. And I'll tell you how you can tell. This x squared we did a while ago up here, this x squared was positive, so it opens up. This one I'm about to do, this x squared's negative, so it's going to make it turn upside down, okay? But y'all, these are tricky. So let's start with f of -2. Now, y'all see there's a negative in this formula. So bring down that negative no matter what. Now I'm going to put in my number, which is a -2. Square that minus 1. So y'all, if you've got a negative in front of your x and you're putting in a negative number, you got two negatives there, okay? Because that negative's in the formula no matter what. And y'all, let me tell you this. These two negatives do not make a positive because this exponent has priority.
Yeah.
So what you got to do is bring this negative down. Now, what is -2 times -2?
4.
So look at that. This whole expression stayed negative. Because technically, this ain't just two negatives. This is three negatives sitting here, ain't it?
Yeah.
2 from the exponent and then the other one, okay?
Yeah.
And then bring down that -1. And let's see, we got a -4 minus 1 is what, a -5. All right, f of -1. I got my negative and then my -1 squared minus 1. All right, so I got to bring down that negative and then hit the exponent. Well, -1 times -1 is 1,
1.
and then minus 1. So y'all check this out. If you've got a negative in front of an x squared, it looks like it's staying negative every time.
Yeah.
Okay, and that's going to be what, a -2. F of 0 will equal a negative times 0 squared minus 1. Well, y'all, that's a 0.
Yeah.
And 0 times anything is a big
5, 0.
big 0. There you go. So you got a 0 minus 1. And that's going to give us a -1. All right, now these are symmetric graphs also. So we know what's coming here, but we'll work them anyway. But I'm pretty sure you'll get a -2 here and then a -5 here, okay? All right, so we got our negative, put in our 1, square that, minus 1. Well, y'all look at that. Bring down the negative. 1 squared is 1, and then bring down that -1. So no matter if I put in a +1 or a -1, I'm getting the same answer. because that little exponent being even is making everything positive that we're squaring, okay? All right, y'all, then finally was f of 2. So I got my negative, then my 2 squared minus 1. All right, y'all, bring down that negative, square that 2, and that's going to be the same thing we got up here when we squared that negative 2. That's going to give me what, a minus 4. Bring down my minus 1, and that's going to give us what, a negative 5. So I'm going to graph it. I would do my 0, -1 first, probably. So here's my y and my x. X squared graph, remember, so it's going to be the U-shaped parabola when you graph it. So 0, -1, 0 is in the middle, go down 1. I'd probably do 1, -2, so go right 1 and down 2. And then I'm going to do -1, -2, so that'll be left 1 and down 2. So always try to get to center and then 1 on either side. But y'all, we said since it was negative, it was turning it upside down, and there you go. Turned that parabola upside down. So y'all, that's the trick on these. They're going to give you all the x values for you to graph. So figure out all the y values or the f of x values, and then get ready to graph them, okay?
Okay.
All righty, so the last thing for the college algebra part of this, let me turn my paper, it starts kerning. So the last thing we look at for the college algebra part is determining if a graph is a function. All righty, so determining if a graph is a function. And this would just be by looking at the graph. There's a little trick we do to determine if it's a function or not. So have y'all ever heard of what we call the vertical line test? And y'all remember vertical lines go straight up and down, right? So a vertical line is straight up and down. So here's the thing. I can use a vertical line to determine if a graph is a function or not. So if a vertical line can intersect a graph more than once, the graph is not a function.
Mhm.
Because y'all think about this, and let me show you what we got going on. So there's my X and my Y. Say I had something like them absolute value graphs, but it went sideways like that. So I run my vertical line left to right. Well, look, it's intersecting this graph here and here. But what does that actually mean? Well, that means this little X value that was right here, say 2 or whatever, what's it got? It's got 2 different Y values, don't it? So if that vertical line can intersect it more than once, that means you got more than one y value. And that was definitely what we said when we defined the function, right? We said that these x's can only have one y value. So this one is not a function because it failed the vertical line test. Now over here, let's say, well, we've been drawing parabolas all day. So there's me a parabola, but look, I'm drawing my vertical line, only intersects it once. No matter where I put this vertical line, it's only intersecting my graph once everywhere. Right? So since it's only intersecting it once, no matter where I put it, that means that these x values only have one y value. So this one would be, yes, a function. So the vertical line cannot intersect the graph more than once, okay? So y'all, now that you know that, let's see how y'all do. Y'all are going to determine if the graph is a function. Alrighty, so there's my x and y, and I'm just going to do an absolute value right off the side of my graph. Absolute value graph, is that a function? Can your vertical line intersect that graph anywhere more than once? Oh, I'm seeing it now. They're popping
Yes.
up. Okay, I didn't see my chat. My chat's lighting up. Everybody's saying yes.
It's yes.
So good job. That is definitely a yes. All right, so there's x and y. So this next one is what we call an ellipse. Almost looks like an egg. Is that a function?
No.
No.
Oh, I'm hearing it. I'm hearing. Sounds like y'all are saying
No.
no. There you go. Good job. Right, because that thing, if you put that line on it, it's
Yeah.
intersecting it here and
Twice.
here. Pretty
That's-
much twice everywhere other than the
Yeah.
little ends on it, okay?
Yep.
All right, y'all, let me see. How about something that is upside down? Is that a function?
Yeah. I would
So
think.
intersecting it once. So pretty much intersect it just once everywhere. So we're
Yeah.
saying,
Yeah.
oh, I see y'all lighting up again. Yes, a good job. Hey, y'all, so I got one more for the college algebra, and we'll be done with that part of this class. So this one sort of comes up, touches, zigzags down, comes up, touches, zigzags down, comes up,
Mm-mm.
and then zigzags down. But the question of the day, is that a function?
No.
No.
Oh, I'm getting a lot of no's.
Well, I don't. Oh, that's tricky.
Oh, that
Me?
hit, but that only intersected it once here. So watch these vertical lines. Intersected it once, intersected it once, intersects it once, intersects it once. Looks like pretty much anywhere I draw that vertical line, it's only going to intersect it one time. So y'all, if you said,
Yes.
yep. See, they try to throw them funny looking designs at you, but y'all grab you a ruler or a pencil and make vertical lines, okay?
Okay.
All right, y'all. So that's the college algebra portion of this. So I couldn't remember if I done some of these support questions last week with y'all or not. So there was only like 7 of them in support. So I'm just going to show you some examples and see what y'all do with these, okay? So this stuff will be support for 2.2. And y'all, mainly this stuff is about adding like terms and parentheses, okay? So what will this give me? N minus 6n. What do y'all think that'll give us?
Mm,
Well, let me ask y'all this. What number's in front of this n?
1.
1.
It's a 1. So that's a 1. Whoops. Well, then what is 1n minus 6 n's?
-5.
Negative 5
5. Yeah.
n. There you go. So y'all, here's the thing. Adding and subtracting, you never change the like terms. All you can change is how many you got, okay? But we can never change the variable when we're adding and subtracting. All right, y'all. So this one's on y'all, okay? 20z minus 15z plus 3z. All right, so what's that giving us?
Two Z.
Oh, how many z?
2.
All right, well, let's see. Oh, I bet you did. Okay, so let me tell you about PEMDAS. So parentheses, which we don't have, exponents, multiply or divide. Now remember, multiply or divide, whatever you do first, left to right, and then add or subtract. But remember, go left to right when you add and subtract. Because see, if this one, if you added first, that gave you 18, and then 20 minus 18 gave you 2, but that's wrong. What you want to do is go left to right. Do the 20 minus 15, which is what, 5?
5.
And then 5 plus 3 gave me 8z.
8Z.
There you go. Okay, y'all. So remember, although PEMDAS has A before the S, it's A or S from left to right. So
Okay.
remember, please excuse my dear Aunt Sally from Little Rock. She's from Little Rock. That lets you know you go left to right, okay?
Okay.
All right, y'all, let's see if we can do anything to this. I got a negative, and then I got a y minus 12 in parentheses. So our trick on this one is to get rid of the parentheses by distributing that negative. And if there's not a number behind a negative, we always treat this like a -1 being distributed.
Okay.
So this negative times that positive y. Well, y'all, negative times a positive
Negative.
is negative. There you go. But now remember, the distributed property says I got to distribute it to everybody inside those parentheses. So what's going to happen when you subtract a -12?
It's going to turn
Positive.
positive.
Because a negative times a negative makes that a positive.
Positive 12.
There you go. So anytime parentheses follow a negative or subtraction, when you distribute it, it's just changing their signs on them, okay?
4.
So this one will be on y'all. I'm gonna give y'all a big one. A negative, and in parentheses, 57u minus 76v plus 26, close parentheses. So y'all, what's coming out of that? Now, I will say this, there are no like terms. So all y'all can do is get rid of my parentheses.
Negative 57u plus 76v minus 26.
Man, that's perfect. Good job. So all we did was what? Distribute that negative to all three of those, this time inside my parentheses, okay? All right, so let me throw some curveballs at you, and I'm going to do an 8a minus parentheses 6a plus 5. So y'all, when you do one like this 8a is not affected by none of this. So bring down that 8a. But now we need to get rid of these parentheses by distributing our negative. So y'all, what's coming out of these parentheses in my next line?
Negative 6a minus 5.
5, correct.
Yeah.
So negative 6a minus 5. So
Mhm.
let me ask you this. Can y'all go further?
Yes.
Yes. Yes.
Yeah, you can.
2a minus 5.
2a minus 5, because that 8a minus 6a is my like terms. Good job. So that gives us a 2a. And then minus our 5. All right, so I'm going to do one more. Number 6 was like this one, so I'm going to skip to 7. And y'all look at this. 10x minus 7 times 2x minus 3
2x.
minus 4.
Hmm.
So I'll tell y'all the first thing I would do to that is distribute. But look, this is a negative and a 7. This whole thing we got to distribute.
Yeah.
The sign and the number. So y'all, I'm going to bring down to 10x. What's next?
Negative 14x.
40x.
Negative 14x. All right, keep me going.
Plus 21
Plus 21
minus 4.
minus 4. Good job. I was trying to see if y'all was going to try to multiply that negative 4 times that 7, okay? But it's not inside the parentheses, so y'all did perfect. So y'all, final answer then.
Negative 4x plus 17.
Because those x's added together got negative 4x. And then the numbers, 21 and 4, what'd you say? Plus
17.
17. Perfect. So y'all, that's all the support's going to do is just getting you used to these parentheses and playing with those like terms, okay?
Okay.
The college algebra part, mainly function notation, sort of getting you used to that. And then that way, next week, we'll deal a little bit more with domain and range type stuff, okay?
Okay.
All right, y'all. So let me stop that share there. So, oh, I didn't even see you had it up there, Caitlin. You had a negative 4x plus 17. Good job. All right, y'all. So, any questions on anything?
No.
So,
Yeah,
y'all play with this stuff. If you got any questions, remember, email me. I usually can answer them pretty quick for y'all
Okay.
and get right back to you.